In this example, we're going to use the discriminant to find when the intersection between the parabola y equals 2x squared plus 2 and the line y equals mx will have no solutions, one solution, and two solutions. So first off, if we want them to have any sort of solutions, or we want to find where the solutions would be, we're going to let the two curves equal each other. So we're going to have 2x squared plus 2 equals mx. Next, whenever we're solving quadratic equation, which this is, we need to get all the terms on one side and let it equal 0. So we're going to subtract mx from both sides, and we're going to find that we have 2x squared minus mx plus 2 is equal to 0. So the discriminant of this uses the a term, which is 2, the b term, which is negative m, and the c term, which is 2. So delta equals b squared minus 4 times a times c. In this case, b is negative m, and we square that, and then minus 4 times a, which is 2, times c, which is 2. So negative m all squared gives positive m squared, and minus 4 times 2 gives minus 16. Next up, I'd suggest graphing this to get an idea of what the discriminant looks like as m varies. So on our set of axes, we'll have delta and the value of m, and m squared minus 16 is another parabola that looks something like this. So we'll have a y-intercept of 0, negative 16, and if you quickly solved delta equal to 0, you'd find that it gives 4, 0 and negative 4, 0. And we'll do that calculation now. So the most important thing is to work out when the discriminant is 0, and then we can work out the intervals where it's greater than 0 and less than 0. So we're going to let delta equal 0, which implies that m squared minus 16 is equal to 0. So plus 16 to both sides, and we get m squared is equal to 16. And now if we take the square root of both sides, we get m is equal to plus or minus 4. So 4 squared and negative 4 squared both give 16. And the plus or minus 4 are these points down here that we found to be the m-intercepts when the discriminant equals 0. So with this information, we need to go through when we'll have two solutions, one solution, and no solutions. So two solutions occur when delta is greater than 0. So for delta to be greater than 0, we're talking about this part here that I'm putting in yellow next to the curve. So the way we can describe that is we want m to be an element of negative infinity up to negative 4 but not included, union with, so also included, positive 4 through to infinity. So that interval notation describes all of the interval where delta is greater than 0, which is outlined in yellow on our diagram. So one solution occurs when delta equals 0, which is what we found up here. So delta equals 0 when m equals negative 4 and or m equals positive 4. Finally, no solutions will occur when delta is less than 0, which is this bottom part of the parabola here that I'm drawing in orange. So no solutions is when m is an element of -4 through to +4, but both values not included, because if they were included, you'd have delta equaling 0.